So what makes carbon unique? What makes carbon so special? Carbon, atomic number 6. Yeah, there are other elements on the periodic table. Yes. We have oxygen, nitrogen, and we have silicon. All of these are very, very important. You know, humans depend so much on oxygen. Nitrogen, very, very important. Silicon, very useful as well. But why is carbon at the top? Why is it that we don't have a branch of chemistry for studying oxygen, but have an entire branch of chemistry for studying carbon? That makes carbon so unique. So that's what we'll be discussing in this lesson. You see, there are a lot of thousands, millions of compounds in this world that have their root or foundation from carbon. So what are some of the unique properties of carbon that sets this aside? The first one we'll be discussing is its electronic structure and tetravalency. So let's have a look at carbon again. Carbon, the 6th element in the periodic table, meaning it has an atomic number of 6. If the atomic number of carbon is 6, what it basically means is its electronic configuration will be 2, 4. Yes, 2, 4. That is the electronic configuration of carbon. But you would remember that carbon needs to have a minimum of 8 electrons in its outermost shell to be stable. But here's the case, it has only 4. So how many electrons are left? They are left with 4 electrons for it to be stable. So do you think carbon would like to lose its 4 electrons? Do you think it would like to lose its 4 electrons so that it will be left with only 2 electrons? Because there's also the duplet rule. Do you think carbon would like to lose its 4 electrons? Or maybe, do you think instead of losing the 4 electrons, it rather like to accept? So these are possibilities you have to think about. So carbon will not like to lose its 4 electrons, but what would it rather prefer to do? Will it prefer to gain 4 electrons for it to become stable, like something like this? Carbon will also not like that, because all of these scenarios are energetically unfavorable for carbon. It's not favorable for it to completely just gain 4 electrons or completely just lose its 4 electrons. So instead of doing this, what carbon would prefer to do is to go under a kind of bonding known as covalent bonding. We already have lessons of covalent bonding. If you really want to understand what covalent bonding is, you can check the playlists on our channel for that lesson, or better still, we'll leave a link to it in the description of this video. So instead of gaining or losing 4 electrons, what carbon would rather do is to undergo bonding with other atoms. What do we mean? Let's show this. Suppose we have hydrogen atom here. Hydrogen has 1 electron in its outermost shell. I think you see that. Hydrogen also wants an extra 1 electron so that it will be 2 electrons in its outermost shell in order to meet the duplet rule. So what would hydrogen and carbon do? Well, carbon will have to bond with 4 hydrogens, one coming to attach itself to the lower electron, the other one attaching itself to the upper electron, then another one coming from this side, the last one coming from this side. So you will see that carbon tends to share its outermost 4 electrons with hydrogen to form something we call methane, CH4. So 1 carbon bonded with 4 hydrogens. In this scenario, carbon hasn't completely received the 4 electrons, but rather it is sharing these electrons with hydrogen. That is what carbon would like to do. And this phenomenon in carbon is what we refer to as tetravalency. Tetravalency. It has 4 electrons in its outermost shell. So these 4 electrons is what it will use to bond with 4 separate atoms. Not only hydrogen, keep that in mind. So the fact that it has 4 bonds around it, that gives us the idea of tetravalency. The next we'll be considering is carbon's ability for catenation, concatenation. So carbon bonds with itself. What does that mean? There are thousands of compounds that we have that exist today as a result of ability of carbon to bond with itself. Without this ability of carbon, we wouldn't have our DNAs and RNAs, and we also not to have the carbohydrates and coal that we have around us. So what is catenation? Look at it this way. You see this compound that you see on the ball. That is 1, 2, 3, 4, 5. That is pentane. So you can see that we have 5 carbon atoms, and the carbon atoms are connected with each other. They are linked with each other. The same thing applies to this. The carbon atoms, we have 1, 2, 3, 4, 5. The 5 carbon atoms connected with each other, and then there is another carbon sticking out from the second carbon from my left here. This is what we refer to as catenation of carbon, ability to link with itself. And this linkage of carbon with itself can form straight chain like the one we have at the top. The one we have at the top is known as a straight chain connection, and the lower one is a branch chain connection because there is one carbon sticking out from the main chain of carbons. Then we also have carbon looping to form rings. This is still catenation of carbon. The bottom line is carbon is the only element that is able to do this, to undergo tetravalency and also form catenation in this unique way. No other element can rival carbon. The next property that we have is the ability of carbon to form multiple bonds. When we say multiple bond, it means double or triple bond. What we have on the screen right now is carbon forming single bonds. So you can see that carbon is having only single bonds around. But this is not what we are interested in. If you take a very close look at the second compound that is appearing on the board, that is the displayed formula of this alkene, the highlighted side shows 2 carbon atoms having double bond between them. So this double bond is what referred to as a multiple bond. It doesn't end it there. You can see that the third compound shows 2 carbon atoms having 3 bonds between them. The line stands for the bonds. So these 3 bonds is also known as a multiple bond. So when we are referring to a multiple bond, what we mean is either double or triple bond. So far we've seen carbon's ability to undergo tetravalency, catenation, and its ability to form multiple bonds. It's because of this unique property that is why carbon is able to form the thousands or millions of compounds that we know around. Something that no other element is able to replicate. So in our next lesson, we'll be considering, let's check really quick, classification of organic compounds. Yes, we'll classify organic compounds, and it will be very interesting. So I think maybe it's appearing already on the screen. Click somewhere to watch our next lesson. Subscribe to Learner's Aid so you wouldn't miss our next lesson.